Hello again and welcome to the next video. So we're actually back with the RiscPC power supply, which I've stripped down, as you can see here. And I've got the board out. I've measured the continuity across the fuse and it's absolutely fine. I'll just show you again. So if we grab our multimeter, go to the fuse, move my arm so you can see that we have, oh, that slipped off, but we have no resistance. Right, a little bit dangerous, but I will show you what will happen if I plug in this connector back into here, which is basically the main power supply connector. That connects to the auxiliary connector. They both share the same position in the circuit, so I'll just nestle this back into here out of the way. Ensure the power connector is off, grab a power cable, plug in the power and power on. So there was a flash from inside that fuse, so I'm not sure if that's actually just blown. But previously, if I switch to alternating current 200 volts, we were getting power up to as far as this capacitor here. So let's check. Yeah, so getting voltage. Yeah, I think that's just toasted that fuse. So I noticed that there were problems elsewhere in the power supply as well. So if I take it out, just pull this out, and then we go over. That's our large capacitor. Now that was charging up earlier, but now that's not charging at all. Something has gone further down the line. One of the things that I'm suspecting is this bridge rectifier. And also, judging by some of the scorch marks here, thinking we've got a problem with these resistors, which if we come closer to the camera, there does seem to be a bit of damage, certainly on this one. So this one here has lost a bit of its sort of paint. I'm not sure if that's a sign that it's popped. That capacitor is fine, so it's these two resistors, or possibly these four resistors. This bridge rectifier. And I think that's what I want to get out of it at the moment. So what I'm going to do is to grab my other camera phone, go to photo mode, just grab photograph showing the orientation of these components. And also this one. There we go. So let's unsolder these. Probably need to just move that out of the way. And smell the soldering iron is warming up. So this one and these four, I think. Let's get the big bridge out first. So that's held in with 3 and these two at the back for the heatsink. Hopefully that's enough heat into that now. Oh yeah, that's beginning to come away. But the problem with this is because it's a heat sink, it's actually going to be taking some of the heat into it. So I'm going to keep the heat applied for quite some time so that we get it uniformly hot. That's getting nice and warm. I think that's that one pretty much off, so let's do this one. Let's get that nice and warm as well. There we go. Now we've got these three little ones which actually hold the chip itself in. There's one, two, and three. So that's that. That's going to be quite warm. I should be able to remove it. And this is a IRF 840, so we need to grab one of those. We probably also need to separate it from the board as well. Obviously, because it's the new one's going to go where that one lives at the moment. Let's come off easily enough. There we go. There we are. There's no external damage, but that definitely is not happy. Now I wonder if my special tester will allow me to test it for whether it works or not. Let's have a look and see if it is. I actually need to work out where I put it. Where did I put my special tester? Ah, there it is. Right, this will be the special Chinese one. Let's see, there's enough voltage in there at the moment. So let's borrow this and there we are. So testing. Reckons it's a resistor. It's not a resistor, so let's try it in K8A. It's a Zener diode, 0 millivolts. Does that mean it's broken? I guess it might do. Let's try it in one of these. Yeah, it still reckons it's a resistor, which obviously it isn't. I think it goes into this K8A one because that seems to give you the most accurate result as to what it actually is. And I don't think that is currently working. Yeah, I think that's unhappy. Ooh, lots of fuses. And that's handy. Handy. I've got a load of fuses out of the VCR, which might suit that fuse that's blown. So I will keep those handy because I know where they are now. Next thing we need to do is let's measure those resistors. Let's upset that box. I'll have to redo that later. Right, that is a known issue. So let's get these resistors out. So we've got these ones here which are definitely showing signs of fatigue and popness. There we are, that's that one. Okay. Let's try this one again. No, I think that one's out. That one's probably out as well, actually. So, other side. So we're looking at R5 at the minute, so let's grab that one out of the circuit. Oops. This needle nose ply not needle nosy enough. I've got another pair, or actually use a very small screwdriver. Wrong type of head, I want a flat head. There we go. Let's gently prise that out. There we are, that's one and two. Right, here is a resistor. Let's see if it is still resistoring. Probably because I didn't get in properly there. Actually, let's use the actual probe. Wherever that's gone. Right, there's the probe. Plug the probe in. So we will go green and red. Start with green and red. Let's test that one. So 97.93 kiloohms. I've got a resistor value calculator somewhere. Let's just do that. So that's 97.93 it reckons. So, right, here we are, resistor. So this has 1, 2, 3, 4, I think. So that's the chubby end. Oh, it's a silver stripe, so brown, black, yellow. Okay, so brown, black, yellow with a silver stripe, and it's measuring up at, so it should be 100 kiloohms. It's measuring up at 97.95 kiloohms, so it's not actually that badly out. However, we will put it to one side pending replacement. That's either brown or red. If it was red, it would be 200 kiloohms. But I think that's actually brown. If it was orange, 300 kiloohms. Trying to see what matches close to it. It's brown, yeah. Okay, so 100 kiloohms. Might be a good idea to start writing some of this down actually. So 100 k ohms on R5. Let's have a look and see if I've actually got some. So R5, 100 kiloohms, 2, 47, 100. There we are. So that's our 100s. And that's brown, black, yellow. So brown, that's brown, orange, black. Unless these have got particularly poor tolerance. Definitely 100 kiloohms. It looks like orange, black, black. Or are they more than one band? Yeah, they might actually be multi-banded. So we have brown, orange, black, black, with a brown tolerance, which suggests that that's 130 ohms. If you go the other way, brown, black, black, orange. So brown, black, black, orange, with a brown tolerance. So yeah, that is 100 ohms. Okay. 100 kiloohms, sorry. Right, we'll keep that to one side. What's this next one? That's brown, black, yellow. That's a 3-band, so that's brown, black, yellow. That's another 100 kiloohms. So R6, 100 kiloohms. Okay. R6, 100 k ohms. one's particularly burnt looking, to be honest. Let's pull that one out. Oh, hang on. Right, might as well test this one. This one looked a bit extra burnt, to be honest with you. Red and green again. There's red, and there is green. Let's start, and that one is coming out at, yeah, I reckon that one's still okay. Oh, okay. Wouldn't surprise me if, you know, aged components, if they are a bit broken. Right, the other ones I wanted to remove were these two. So R41 and R40. So let's remove both of those. So that will be these two. Because they do actually, those ones look like they have actually split, so it would be interesting to see what happens when I bring those out. So, ready on the sucker, ready on the soldering iron. Here's one. There's two. There's three. And four. There we go. Secretly hoping that these shatter when bringing them out, because that will confirm my suspicions that they're total. Right, they're a different value. So R41. Let's measure its value with this and see if it is still resistoring. $37.92. So that's a gold band, but we have a, it looks like orange, white, orange. So orange, white, orange. Orange, white, orange. 39 kiloohms. And this one is measuring out at 37. Slightly low. Still valid. So, however, there is damage to that resistor, so it may not be doing its job properly. R41, 39 kiloohms. See if we have replacements for those as well. Right, next one is R40. And this is the one that, if any of them's going to break, it would be this one, as it's literally losing its external coverage. However, it's come out in reasonable tact. That's orange, white, red. So orange, white, red is 3.9 kiloohms. So let's measure it out on the tester. Okay, on the tester it is measuring 37.86 kiloohms. That's not right, surely. So that is... or is that brown? Oh, that might be brown. So brown, white, orange, 19 kiloohms. And it's measuring out at... so that's actually high in value, so that's actually resisting more than it should. Orange, white, or brown, white, orange. It's definitely a brown. Definitely white, definitely orange. With a gold stripe. Plus or minus 5%. That... should be 19 kiloohms, so R40 should be 19. Okay, 19 kiloohms. So we're looking at two 100s, 39 and 19. So let's see what we have. I've got a 20, 10, so could do two 10s, I guess. 22. Let's just measure that one again. 19 kiloohms. Versus orange, black, sorry, brown, black, yellow. Brown, black, yellow, 100 kiloohms. Right. So 100 kiloohms, 39 kiloohms, 19 kiloohms. $22 kiloohms, too low. 47 kiloohms, too high. That's okay, I'll need to get some more resistors for that one, so I won't replace anything today. So ideally I need some more resistors. Also I need one of those rectifiers as well. So something else to check is there's quite a chunky diode on here which could potentially cause us some misery. There it is, D5. So D5, which was next to our suspects. Let's see if D5 has gone open. So ohms, D5. Yeah, I think D5 is open. So that diode has gone open. I'm measuring it from the wrong direction. Let's try it again. Yeah, it's open circuit. Let's try it. Didn't flip it up prematurely. Let's try it with a tester. gently applied, like so. There we go, there we go, there we go, there we go, there we go. Oh, it's still measuring the diode, but I'll try and put that through it. It doesn't seem to work. Just testing this. Sort of use this to rudimentarily test the transformer, and yeah, I don't know why I'm bothering to do that. I think that diode as well needs to come out. Okie doke, so let's grab a photo of the diode. That's D5 we're looking at. Just want the orientation. There we go. And we may as well unsolder that one as well. So let's unsolder. There's one. And two. I need to give it another blip. Okay. There we go. Right, let's see if that one comes out. Ow, that was hot. There we are. So that is a, let's write this down. That's actually quite toasty in the old fingers, between the old fingers. We're looking at diode D5. And we're looking at, it's either an IN5406, IN5406 GD, whatever that means. Hopefully that's the part number. Right, so we'll need one of those as well. There's not really much more I can do with this today. I think I've identified our problem components. So we're looking for this rectifier, which I need to write this down. That is an INF840, sorry, IRF840. 840. Definite damage to those resistors. That one there, for example, it's got a lot of paint coming off of it, so they've definitely popped. There's also been a bit charring around this area of the board, so that's definitely a concern. And obviously we need that new mains fuse as well. However, for the minute, that's pretty much all I can do with this machine. What I'm going to do is just pack it all away, put the power supply back into its cradle. So effectively just do this really, just put the power supply back in like so, so I keep everything with it. So you see it locates under these little tags here, so it needs to come in like that. Then we have the 2 screws, which obviously hold it, all of these screws, which can go back in there as well. Components, heatsink for the rectifier, another couple of screws. Also pop the power switch in there as well, so we don't lose that. We can just gently put this over loosely, so everything is contained within there. And then we can store that, funny enough, we can store that in the top layer of the RiscPC, which I'm just going to do now. So it's a bit scrappy, but you can just plop the top layer back on. And there should be enough space. Mount it in there sideways. Yeah, that'll do. Keep all of the locking pins together. So put those in there as well. And there we go. And that can sit out of the way for a little bit under my desk until I get round to supplying it with some new components. We'll certainly see if that actually resolves our problem. However, for the minute, that actually concludes today's adventures into this Acorn RiscPC. I'd like to thank you all very much for watching, and I will see you next time. Obviously hit the like button, notification bell and everything else, and see you soon.